Hello, and welcome to Tech Connects, Dice's podcast where we dig into the topics on tech hiring, recruiting, and careers that matter to you. I'm your host, Nick Kolakowski, and I'm going to talk to great guests every month about the current state of the tech careers world, including the tech job market, the hottest tech skills, what companies are doing to attract and retain tech pros in a historically tight market, and much more. Our latest guest is Ben Marx, who's director of software at True Anomaly, a startup focused on space-based security and sustainability. Their current projects include Jackal, an autonomous orbital vehicle that can swoop close to other satellites and carry out surveillance imaging, as well as a new manufacturing facility in Colorado. As you'll hear during our discussion, Ben has deep experience in software, which comes in useful when you're trying to write code for something zooming around orbit. There's not a lot of room for error, as you can imagine. There's been a lot of buzz about space lately in the tech arena, and I was really curious about what it takes for software developers and tech pros to break into this rapidly evolving space. Pun intended. Let's break it down with Ben. Space is a fascinating topic for me, and I think for a lot of our listeners, and then a lot of readers for Dice's content, because I feel it's one of those things where you mentioned the words mobile app development, for example. Everybody knows what goes into mobile app development. You know, you learn your Kotlins, you learn your Objective-Cs and so on, you know, and you kind of know what goes in that. But space is one of those arenas that everyone's fascinated in, but nobody I feel the people outside of that community don't really have a firm grasp of the skills, the processes, where it stands as a commercial enterprise and things like that, aside from what they might see in terms of SpaceX and everything. So just to kick off, I wanted to delve into your background. Obviously, you spent a decade involved intensely with the Elixir programming language, and now you're with True Anomaly, and you're using Elixir in that context. I'm fascinated in terms how just your story in terms of Elixir, and then how does that actually intersect with True Anomaly and space and everything else?
Yeah, sure. It's a great question. So my background, I don't have a degree in computer science. I studied philosophy and economics. But when I was young, I liked playing with old Commodores or 46s and these kind of things. And it wasn't until after I graduated that I found that that neither philosophy nor economics would be substantially paying like a job, and programming sort of combines a lot of those elements in that. And so I started working at different startups. The first one was a small startup in San Francisco. And like a lot of other companies at the time, we were using Ruby on Rails. And then I started getting interested into functional programming, and I actually started learning Clojure. And I was starting to look for jobs in Clojure. And then my boss at the time had said, "Have you ever heard of this language called Elixir?" And I was like, "Well, no." And it was written by Jose Valim, who is heavily involved in the Ruby on Rails community. And it was built on top of this language called Erlang. And Erlang has this prologue syntax, which is very strange, at least compared to most modern programming languages. But the fact that it was familiar and easy to work with meant that it was an appealing language to start with, because it had the functional background and it had the approachable syntax of Ruby, so it was very easy to get into.
Cool. And how does that? And then from there, how did you get into True Anomaly in space? Like, what was the next step of that journey? How did you get there?
Yeah, it's definitely been an interesting few years in terms of different jobs that I've had. Right after I started learning Elixir, I started working at Bleacher Report, and that was during this time when they were rewriting their platform in Elixir. And so that was a great experience because Bleacher Report has millions of users. We send out hundreds of millions of push notifications, and content is delivered on demand to the user. So there's lots of interesting technical challenges to scale there. And then after that, I joined a startup called Subspace. And the goal of that startup was to have a low latency global network. It didn't quite pan out. But my boss for part of the time there was this guy, Dan, and he was VP of engineering at SpaceX, software engineering at SpaceX. And so we talked about space quite a bit. And then he was an advisor for True Anomaly. And then he said, "Hey, this could be an interesting next thing." And so Evan, the CEO at True Anomaly, and I had a first conversation, and then everything went pretty well from there. And then I joined True Anomaly.
Cool. So Elixir, the ideal programming language for all the space related stuff you're doing at True Anomaly. I imagine that Elixir obviously checks those boxes because you're using it. I mean, is it low latency? I mean, like, kind of what makes an ideal programming language for space or for like kind of cloud based, space based operations? Because it's really fascinating.
Yeah, no, it's a great question, and I think there are different things to think about. It depends on what part of the application you're talking about. For the flight software on the vehicle is another question. The simulation environment is another question. What are the characteristics that you need in order to have a successful application? And so, in my view, Elixir is a great choice for a space application because if you abstract the space component away from the system that we're building, it has many overlapping characteristics with a terrestrial system. You want it to be low latency, we want it to be fault tolerant, resilient, scalable, these kind of things, and so we're able to provide those sort of same guarantees that Erlang and Elixir offer, and just do it in the space domain. And then there's something called a native implemented function in Elixir and Erlang, and what that basically is a foreign function interface for you, where you can basically embed another language like C, Rust, or C++ into Elixir or Erlang, because Erlang and Elixir's strength is concurrency and fault tolerance and scalability. It's not speed like C or Rust, so you can marry those two when you need them.
Yeah, I imagine fault tolerance for the things that you're working with is probably pretty essential. I mean, you can't really. I mean, it's like it's wow. In terms of, so I mean, True Anomaly is positioning itself at this cool intersection where you have software. It sounded, based on what I was reading, like there's a whole generative AI component, and obviously the spacecraft, the orbital craft element to it. And all those three of those things involve, kind of very, like just kind of this highly specialized talent. And I'm just wondering, I mean, and this, obviously a lot of people who are listening to this program are interested in breaking into things like this. What sort of skill sets? I mean, we talked about, there's the basket of programming languages, but then, I mean, kind of what else do they need to break into it if they're interested in it?
Yeah, and this is something that, when Dan had first told me about True Anomaly, and I first talked to Evan, I was kind of like, why do you want to talk to me? Like, I don't have a space background. I don't have the domain knowledge to build a specialized space system. And their idea was this idea of sort of this beginner's mindset. And I think this is what I've tried to apply to other companies that I've worked with as well, where the idea is that you come to a problem with fresh eyes and you solve them. And you solve that using this novel way of doing that. Of course, that doesn't work if you don't have the experts on staff to say, yes, this will or will not work. Because, of course, we do have astrodynamicists, and we have space operators, and we have people who've flown and operated satellites and designed and doctrine for how we fly satellites. So it's those two things in common. And I think, one of the most important aspects is finding people who have early stage startup experience, because that's quite unlike anything else, as far as companies go, because there's so much instability and so much uncertainty in early stage startups, and you really have to have a certain type of person who can roll with the changes and understand that what's true right now might not be true, in a few hours or tomorrow or next week, and how do you design your processes in such a way that doesn't cause things to blow up when these things change.
Yikes. I imagine that, I mean, to that point about things blowing up and whatnot, there's probably a steep learning curve for people. I mean, especially people who aren't coming from an aeronautical background, in terms of like not only the language, but also, I mean, basic physics and things like that. I mean, how much, I guess what I'm asking is how much of a learning curve is there when you get into it? I mean, for you, for anyone else who's into it.
It's definitely been a higher learning curve than other jobs that I've been a part of, just because there's so much to understand, and not least of which are the number of acronyms that are used in both the space domain and sort of the other government domains. But again, the way that we try to structure the work is in such a way that we put people in a slightly uncomfortable position, not in the deep end without any support, but here's a little bit, you have this understanding from your previous role. This is why we hired you. And so now we're going to give you this little bit of, this part of this feature that we're going to build. So you're going to start to learn and get an intuition for some of the things that you will be building. Because again, like, especially on the software side, I think this is less so on the hardware side and on the spacecraft side, because you have to have the domain knowledge in order to be successful. but from the software side, if you can sort of abstract away what the details of what you're doing, because we're building APIs to connect things, to send data back and forth. If you have a good understanding of those connections, you can build on the rest of the space domain knowledge that you need over time.
Interesting. I mean, it sounds like that's kind of a complex engineering culture in a certain way, that you have your software engineers, you're working on this, and then you're also interfacing with the orbital craft kind of portion of it as well. I mean, how do you create a culture where, you mentioned this kind of a moment ago, where you're moving at a certain degree of speed because you're a startup, but then you've also got these really narrow tolerances and so on, and you're interfacing with people who handle hardware. I mean, what does it go into building a culture where it's successful in terms of that, in terms of getting everything done?
Yeah, I think two big important things are one, don't be afraid to say how you feel. Like we need to be expressive. And two is also a culture of saying no. In the sense that, like, we're doing, we have very ambitious goals, and as we need to say no to stay on the narrow path that we need to do in order to be successful, because we can spend any number of hours or days or weeks improving this or that part of the system that isn't, strictly speaking, necessary for our goals we have for this year and for the initial success of the company. Because we have many, many years to build out this system and to build out the way that we want it to be. And the way that you do that is by bringing the right people in the room, talking about something, and then ultimately saying, no, I can't do this, because if I do this, then we can't do that. And part of that is also we've grown quite a lot over the last year, but again, given the wide breadth of things that we want to do, we're still a small company. And so we need to, again, be very rigorous and analytical about the things that we do and why we do them and when, so that we can continue, so that we can be a successful company, basically.
In terms of the growth and everything like that, you were recently there's a whole spacecraft manufacturing facility that you just opened. I mean, which is really cool. I mean, like the idea of having like a facility for that is really fascinating. I mean, is it the sort of thing with that where you're on site and like kind of participating in the engineering? Is it more something where you're off site and collaborating? What goes into building a facility like that? It's so cool. I'm just wondering I have no idea about it, obviously.
Yeah. Well, I mean, to be fair, Sean Ozdemir, who's our director of spacecraft production, would be the better person to ask about that, because that was sort of his. He was in charge of that whole process, which is it's actually been one of the really cool things, because I live in LA and the facilities in Denver. So the first time I was there, it was an empty factory, and I go back about once a month, give or take. And each time I go back, there would be more and more of it, until now the facilities. It's ready. Like we're making the spacecraft, and it's been a really exciting thing to see this empty building transform in basically 6 months into this facility that it is now.
Cool. Yeah. It blows my mind that, because I mean, for so many years it was just this idea that NASA had obviously its massive facilities that it was using to create spacecraft, and the idea that you now have startups that can build something out of essentially a warehouse facility and create these things that then end up in orbit is amazing. I mean, it's nothing that ever really grows old for me whenever I think about it. And I'm really pumped to see where it's going to go. On the software side of it, the other thing too, because I talk to a lot of engineers and developers and so on, and the rise of generative AI and chatbots and everything else is a huge factor in pretty much every industry. You talk to people from healthcare, manufacturing, et cetera. It's all involved in that. And I imagine it's also, in terms of what you're doing, in terms of space and startups and everything else, it's also a factor as well. I don't know how big of a factor, but I'm curious about that, whether it's something that's sort of on your mind and how it's being integrated into your tech stack and everything that you're doing.
Yeah, I mean, we don't. There's something called ITAR, which is the International Trafficking in Arms Regulation Act. So there's some which we have to subscribe to do the technology that we're making. So there are a lot of restrictions on things we can and can't use. Some of the open source things, or some of the commercial products that would normally reach for in previous jobs, we can't use. And so it's a similar thing with ChatGPT and these other AI assistants. So we're basically doing the things that we would do, without that. Of course, the the artificial intelligence agents that we're developing internally, those are exempt from that because we're developing them ourselves. So it's kind of an interesting thing because people have asked like, oh, can we use this or that, and we are on the cautious side of not using it.
Yeah. It seems that, I mean, a lot of companies, like, for example, I was speaking to somebody at Google the other day. And they also, I mean, it seems like all these, because people are, I don't know if they're concerned that the large language model is going to scrape internally or whatever, but it seems like a lot of companies are kind of tiptoeing and being very cautious about that with good reason. I mean, it seems like based on that.
Yeah.
What? Sorry.
Oh, no, go ahead.
Oh, no. I was just going to say, it seems, I mean, for every company and engineer who seems like they're running headlong into Chat GPT and generative AI, it seems that there's sort of a good deal of caution warranted, especially if you're doing highly specialized thing.
Right.
I guess, I mean, the other thing about this too that I'm wondering, I mean, SpaceX and Blue Origin and all these commercial companies have been around for quite some time. True Anomaly is a lot younger than that, and there's a couple of other space startups as well. And then beyond that, you have NASA, which has been operating since the 1950s. And so, in some ways, it seems like space is a very sort of mature. I mean, we understand the physics, we understand how to launch things, we can put people on the moon, et cetera. So, on one hand, it seems to be a very mature, I don't know, you really wanted to call it an industry and art, very mature art. But then on the other hand, you have these startups like True Anomaly that are kind of creating these new exciting things. And I'm just wondering, where is all of this going? I mean, what does sort of space look like right now? And where is it going in 5 to 10 years? I mean, is this a market that's going to explode with all sorts of commercial operators and startups and things like that? Is it still going to be like a handful of key players? I mean, how do you think it's going to go?
Yeah, I think when I talk to people about True Anomaly and why it exists, it's almost like a quintessential startup story. The founders had this experience in the industry, and they're like, we can do this faster, better, more efficiently, and so let's do that. And so it reminds me of startup companies, from 10, 15, 20 years ago, where there was this old way of doing things, and then these new technology or new modes of production or whatever came up. And this is how you saw this wave of startups. And, right now it seems like the space industry is exploding with startups right now. So I would expect that to continue. It seems like I think most of it is mostly in satellites and in things like, metrics monitoring, ground control software, these kind of things. I don't think that there's going to be, I think SpaceX is probably going to be hard to have some competitors to that, other than the ones that you mentioned before. But as far as the actual software around controlling satellites, how you build and design your satellites, how you manage your inventory, even how operators interact with the satellites, both internally and externally to their companies, like those are all ripe for development for startups.
In terms of, I mean, since everything's getting so crowded up there, to a certain degree, I mean, there's satellites currently operating. There's things that have been dead up there for a while. Is collision avoidance a software thing? Is it just a matter of talking to other companies and governments and saying like, here, this is all of our stuff, and we're going to do our best to avoid? I mean, can you program for that kind of thing? I mean, how does that work?
Yeah, sure. I mean, collision avoidance is something that we're developing as part of our software as well, because that takes in a number of different factors from publicly available data, from private commercial sources, working with other companies, and then as well as the satellites themselves, and then of course there's a lot of safety involved in when you can maneuver and why. So of course that's a thing that we take very seriously and a prime concern.
I mean, you have to. I mean, considering the amount of money and effort and things like that, I mean, the last thing you want is bonk. Yeah, no, it's not.
Yeah,
that's really not good. For people who are interested in studying Elixir, what's your advice on that? I mean, where should they start? What should they do? I mean, yeah,
sure. So the Elixir, one of the great things about Elixir has been the big influence and impact on documentation. So I would say go to the Elixir website itself. There's a great tutorial to tell you how to install the language and basically a laundry list of all the things that the language offers, so you can get a taste for it and have a good sense of it. And there are a number of really good books on Elixir. Probably my favorite book is Elixir in Action by Sasa Yurik. That will, if you've done the tutorial and you've played around with the language and you want to learn more, then that's the book to get.
And that's it, folks. Here are some takeaways from the conversation with Ben that I found particularly interesting. First, you'll remember Ben mentioned he studied philosophy and economics, worked at a number of different startups, and experimented with different fields before finding his way into coding in the context of space. For software developers and other tech professionals out there, his experience just goes to show that your skills and experience can translate into many different fields. It's just a question of what interests you. Second, if you're managing a complicated software project, it's important to evaluate languages and tools in the context of what you need done. For example, Ben chose Elixir for True Anomaly space applications because it's fault-tolerant, scalable, low latency, and more. Even if you're new to a particular industry and you feel like you've been thrown into the deep end, you know how languages and tools work, and you can build your success off of that. Third, if you're tasked with helping to develop an internal software culture, keep two things in mind. First, don't be afraid to be expressive and speak up about what you think is working well and not so well. Second, it's important to know when to say no. Sometimes you need to turn something down or go in another direction in order to succeed. Saying no can save a lot of time and effort in the end. We've covered a whole lot of other topics, of course, so give the episode a re-listen if there was something you missed. We'll see you next time, and remember, Dice is your best resource to find the tech talent you need to fill your open roles, and for tech pros, the best place to grow your tech career.